Hello guys, this is Srinivas, the developer from the developer channel. Today we are going to solve the SKIDMARK daily challenge of 10th July 2021. Here this is the problem, cities count with towers. The program must accept a matrix of size R-C and then the matrix which will contains three kind of characters which is nothing but 0, capital S and capital L. The capital S and capital L represent the uh, tower and zeros represent the cities. We just need to find the cities which has the what signal. Like the small tower can provide all the cities around itself, like nearest cities. But the larger thing can provide up to two nearest point, like this. This is the area that the largest tower can give. 1, 2, 3, 4, 5. 5 cross 5 matrix, and this is 3 cross 3 matrix, I guess. Yeah. Now we just need to find which total count of cities which has the signal. Let's see how this is happening here. First, let me take those 8 cross 8 matrix. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 3, 4, 5, 6, 7, 8. Wow, that's a perfect box according to row, but not column. Okay, here where we have S, just have S here. Yes, come on. And where we have 1, 2, 3, 4, 1, 2, 3, 4. Here, I guess. And then L in this one, no, this one. So, and also there is one more S. So if we consider these things are just towers, and if we start filling the signal space by some another characters, I took a hash key for that. So these three will contain signal. So this will become black. And this will contain sorry, this three will contain black colored hash key 1, 2, 3, and here also we will get the 3 cross 3 hash. Likewise, we have to check for the above row, below row, and the current row, which left index, right index, and also the current index. It's like a Rajini movie, right? I'm copying this hash. I'm pasting here. 1, 2, 3 above row completed, and then current row from left to right. Likewise here also we have to do that if we just a 0. So this will become, and for L we just need a 5 cross 5 matrix, right? So I'm need to took above 2. This will become black. Since this is not a 0, we can skip these three values, and this will be black. And for I plus 1 for current I, and I minus 1. Sorry, this should be the I plus 1, and I plus 2. Likewise. So if we count on those hashes, we will get 41. Let me check. 1, 2, 3. This should be 9, 10, 11, 12, 13, 14, 15, 16. 16 plus 10 will give you 26, 36, 37, 38, 39, 40, 41. Yeah, totally we got 41 cities with tower. Likewise, we have to do the same operation for all the things. We're just going to implement this logic, which is nothing but first we will find for the tower. If it is a small tower, we will check if the above index is available and also below index is available, and if is left is available and right is also available. If these things are available, we just change those zeros into hash. If you encounter something other than hash or s or l like that, we just leave as it is. First we will get row and column input. This is separated by space, right? So we have to map those values. Map of in comma input of dot split. We just need that value in a integer data type, so that's why I have specified int here. Now it's time to get the matrix. Matrix equal to input dot split, so it will obtain a list of space separated values, and this should be occurred for r times, right? For I in range of r. So now we have the row and column and also the matrix. Now it's time to check for the presence of small tower and large tower. For I in range of r, for j in range of c, which is nothing but column, we are just going to traverse all those values. If we encounter if matrix of I, j equal to s, then we have to change those values, right? So for that, I'm going to define a function called small change. Small change of this will contains list and I, j position. So we just need a I minus 1 above, I plus 1 for below, and I for the current, right? So I'm just going to do the same logic here. Change of L comma I comma j. Small change of L comma I plus 1 for below and j. Now it's time to implement or define a function for that. Def defining small change function, which will contain list and I and j value. So we have to check if I less than r and I greater than minus 1, we can do operation like that, because we can't able to go beyond or above the given range, right? And we have to do the same operation for column also. If j minus 1 greater than minus 1, then do something like L of I j. This should be matrix, I guess. I have given a name L for that function. Matrix, matrix, matrix. L is nothing but a list. So list of I j minus 1 equal to 0 if this case is true, then update the values of I and j minus 1 with hash. And if j smaller than c, which is nothing but a column, and if, why don't we just do both thing in a same line, so it will be more meaningful and readable, right? Since this is an uncondition, it won't check for the second condition or second case if the first case fails, so we don't have to worry about the index error. If j smaller than c and l of I j equal to what, 0, then l of I j equal to hash. If j plus 1 less than c and l of I j plus 1 is equal to what, 0. You got it right. Then update the value of l of I j plus 1 as hash. So this will work fine for all the small, I guess, small towers. Let me check. Here I'm passing a 4 cross 4 matrix of 0 0 0 0 yes, and yes 0 0 0 and 0 yes 0 0, and this one will contain 0 0 0 0. So we should get this range filled by hash, and this range filled by hash, and this range also filled by hash. Like, we will left out all just these three cities without tower. Wait a minute, I think I haven't mentioned anything to print. So for I in matrix, print star I. I'm just passing the same value. We got, yeah, this S tower contains this range, and this will cover this range, and this will cover all this range. So this will be the left out cities. But we just need to change that S also, right? So if we do that condition here, it may what? It may overwrite while putting signals on or converting this case. So this L may become a hash, so we won't cover this range. To get rid of that, I'm specifying here matrix of I j equal to yes, not yes, just hash. So if I didn't do that, and instead of 0, like if I mentioned or yes like that, we will get or encounter some kind of problems in our logic. We don't show any error, but we may get some logical but problems. Whoa, whoa, whoa. This should be L of ij in oh yes, this is 0, yes, so it's not. We have encountered that error because this is the or condition and this is a true value, so it just passed all the condition. So that's why we got index out of range. As I have told, we have get like these ranges are uncovered because while traversing this tower just override this tower. So instead of considering this space as a tower, it just considers a signal. So these things are left out. To get rid of that, we just need a condition like that what we have mentioned here, and the minor modification will be done here. So if we pass our output our same input, we will get a proper output. That's what we really need, right? So the same operation will be happen for the larger tower, but with some little modification. Here if matrix of I j equal to L, and matrix of I j equal to hash. So the same operation, LA large change of matrix I minus 2 comma j large change of matrix I minus 1 comma j large change of matrix I comma j. Like the same operation will have been done for the rest of both. I plus 1 comma j and I plus 2 comma j. So we just need to define a larger change function, or else why don't we just define a function that will work for both. We can do that with some specified keyword like additional flag values, like if it is a L, just go for this iteration, and if it is just yes, just go for that kind of iteration. But I'm not going to do that. Large change L comma I comma j, we just going to copy paste the values here, and we are just going to add one more condition here, like if j minus 2 greater than minus 1, then j minus 2 will become modified. Likewise j plus 2 also modified, plus 2, sorry, this should be c, and this will become plus 2, this will become plus 2, and this one also. Like this became minus 2. So if we pass our input here like 8 cross 8 matrix, and this will contains what, oops, I haven't saved that. So 0 0 0 3 4 5 6 7 8, I guess. 1 2 3 4 5 6 7 8, yeah. And here yes 0 0 0 S 0 0, and here we became 0 0 0 0 0 0 0 0, and this will contains 0 0 L 0 0 0 L 0, like that. No, not here. I'm going to do that. How many things are left? 1 2 3 4 5 6. This will the so this is what we have got. This yes, just take care of this range. So this range has changed. So this 2 is left outer, and this will take care of this 3 range. So yeah, hope these things are working fine. But we don't need to print the pattern, we just need to print the count, right? So for that I'm just going to declare a variable count equal to 0. This is nothing but a cities with tower. What you have just going to do is count plus equal to I dot count of hash. That's it. Finally print count. So if we do that, we got 52. That's kind of weird. So 3 cross 3, 3 cross 3 become 9 plus 9 18, and plus this 10 11, and then this 1 2 3 4 4 8s are 36. 36 plus what, 18. Yeah, since I was bad at max, hope this is the correct value, or else we can do some already defined values. 0s 0 ss l, like 0s 1, since this is a 5 cross 6, right? 5 cross 6, 0 s 1 2 3 4 5 6. 1 2 3 4 5 6, 1 2 3 4 5 6, and yes, and then 0 0 l, I guess. 0 0 l 1 2 3, everything will be 0, I guess. So we got 25, but we got 26 here. How? 1 2 3 4 5 6, 0 s 0 x 1 2 3 4 5 6, and we have passed s double 0 double 0 s double 0 double 0 s, and then 0 0 l. Like this should work, right? So according to the range, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. What? Okay, let me print those values. So print star I. Did I specify anything now? 1 2 3 4 5. Okay, this is 0 and 0L. So 0 0 0L. Yes and yes, yes and yes, and then 0 and then yes. Yeah, think the output is like input are correct here. So according to our logic, this 3 cross 3 get, if we count on those, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. I think this is the left out part, like this here should cover this one also, right? But this is not covered. This is because I plus 2j, j plus 2, this is I, and this is j plus 1, j plus 2, I plus 1, j plus 2. Why this is not happening? I plus 1 and j plus 2, j plus 2 smaller than c. Yeah, this is the one which just caused the bug. This is my bug. Wow. So we don't know how to print all those things. I think everything works fine. Other than that, that's it guys. That's it for today's video, I guess. And here, this is the code for your view. I have no idea how to sort those values, so you can pass and see the code. Okay guys, see you soon with something else tomorrow. Until then, bye.